Well, now we begin. Good morning, good afternoon, ladies and gentlemen. I can see there are people from practically everywhere. We see people from Argentina, from Chile. I can see people here even from Qatar, from Indonesia, from Italy, Germany, Netherlands, Egypt. Many more places. So welcome everyone. Very good morning or very good afternoon to you. So today we're here to talk about desert locations and desert conditions. And as you know, a few years ago, maybe 10 years ago, when we began, actually looking into these conditions, we didn't know very much about what specific equipment we needed, how we can do the O&M properly, what sort of specialist equipment we need. Well, now with time, this is all changed and we know a lot more than we used to. And today we're learning a lot more about specifically bifacial PV trackers. And as you know, bifacial PV technologies are growing very strongly and very fast. And automated cleaning, which is a very important thing, especially when you're in a very far away location. So with me today, I have three experts on the topic, and I'd like to ask them to introduce themselves. So Cedric, please, if you could unmute your microphone and introduce yourself.
Yes, good afternoon, everyone. So my name is Cedric Broussillou. So I'm Research Program Director at QEERI, which is the Qatar Energy and Environment Research Institute in Doha, Qatar. I've been working in PV for quite a few years now, 15 years, and previously was working for a photowatt manufacturing company in France and part of the EDF group. I've been in Qatar for a few months now and leading the team for energy conversion.
But today you're joining from France, correct?
I am.
Yeah.
I'm still,
so I'm Madrid, France. Okay, let's go. Miguel, please, could you unmute your microphone and introduce yourself?
So thank you very much, Belen, for the introduction. Well, my name is Miguel Pozuelo. I'm Key Account Manager for Soltec Trackers, focused on the Middle East region. I've been working for the last 5 years in Soltec, in Mexican, European, and now Middle East market. And I'm following a lot these two technologies, both bifacial technology and automatic cleaning. So very happy to be here supporting you.
Thank you, Miguel. And he's based in Madrid. We can hear you very faintly. So when you present, I'm going to ask you to hold your microphone closer, but for now it was okay. Okay, Bin, could you please unmute your microphone and introduce yourself?
Hello, everyone. This is Bing from China. I'm the International Business Director of Tetra Electronics, which is majorly in the business of robotic cleaning. And I've been with the company for the past 3 years, and we started from the mainland China. Mostly the projects were done in China, but nowadays we're expanding the international market.
Excellent. Thank you very much, Bing. And you're based today? Where are you joining today from?
I'm currently in Beijing right now.
Beijing. Okay. So as you can see, very international crowd here today. And I'm going to tell you a little bit how it's going to work. We're going to have 3 presentations. And I'm actually going to ask the first speaker to prepare his presentation. Cedric, if you prepare your microphone and your presentation. Whilst he does that and he gets ready, I'd just like to tell you a little bit how it's going to go. If you are familiar with our webinars, it's not that different. We're going to have a presentation from Cedric, one from Miguel, one from Bing, and then we'll take the questions. You can send questions, but you have to send them through the Q&A box at the bottom. Okay, there is in the toolbar says Q&A or questions and answers. Send them through there because they kind of get lost in the chat, in the chatter. So for us to be able to manage them properly, please send them through the Q&A box, and then we'll deal with them at the end. We'll have some time for that. I just wanted to let you know that we are recording the session. So one of the questions we get all the time is, can I get access to the recordings and the materials? Yes, you can. The speakers will send us the presentations thereafter, and we'll also have the recording available for you to review thereafter, and also their contact details are in the presentations. So without further ado, I'd just like to ask Cedric, I can see your presentation perfectly. It's in big screen, so go ahead and start your presentation.
Great, thanks. So good afternoon again, everyone. So I have the privilege of starting this webinar today by giving you a presentation about bifacial photovoltaics and trackers in desert location, and I will focus on the environmental perspective. So the presentation will cover both a review of the data which is available in the literature, as well as some own research material. The research is performed by the energy conversion team and the air quality team of QEERI. QEERI is the Qatar Environment and Energy Research Institute, which is part of Ahmad bin Khalifa University in Doha, Qatar. I'm the research program director of energy conversion, as I mentioned, and I will be leading you through the slides. So I am starting with the world precipitation map because I wanted to show you the amount of land on Earth which receives less than 10 inches of water every year. You can see that's the part in beige, and which I've circled a few in the rectangle, red rectangles. You can see that the whole MENA region, North Africa, Middle East, part of Pakistan, India, further in China, and the large chunk of Australia, South of Africa, and Latin America is concerned with this. What is interesting is that in Doha, for instance, we have only 3 inches of rain, and all those parts are arid with less than 10 inches of rain per year. That's interesting to look at because it's actually one of the climate zones which is the largest on Earth. It amounts to 30% of the emerged land. And this is a place when there is a lot of sunlight, which is linked to the fact of this being a desert. So if you look at the maps, the global horizontal irradiation map and the albedo map, which you can find in the internet, you will see that there's a good correlation between the amount of energy that we receive on the ground in this area, especially the MENA region, which is the one I will be focusing on. And the albedo is also really high. So I'm not going to go into the detail of that because I think that most of you will know what it is. If there are some questions, I'll take them later on in the question session. But in the MENA region, we are usually between 2,000 and 2,700 kilowatt hour per square meter. And we have an albedo, which is between 0.3 and 0.4, which means that 30 to 40% of the light can be reflected from the ground. So that is very significant. And that is why it's interesting to have bifacial modules, as you can see the little image on the bottom, where light is collected not only from the front, but also from the backside, either because it's diffused from clouds or from the ground. Continuing with the comparison between the GHI map and the other maps, I want to show you here the climatic zones, which are the Köppen-Geiger classification. And you can see that once again, all the MENA region, North Africa, and all the peninsula is both red when we talk about GHI, but also in the climatic zone, which correspond to the desert area. So it's both normal and surprising, because it's normal because we have definitely the same climate, but it's surprising because if you look at if you zoom in, there are actually no differences which are really spotted by these climatic zones when you compare Saudi Arabia, Qatar, Oman, and so on. And in fact, if you look at the climates in more detail, comparing, for instance, Doha and Riyadh, you can see that on the top part, you have the temperature profile, and it is rather similar. It gets a little bit colder in winter in Riyadh, but more or less the same aspect you can see. But that's not true when you look at the humidity. The humidity level is completely different. In Riyadh, it's mostly dry throughout the year. In Doha, we have a large period of time between July and October, and even worse between August and September, when there is a high humidity because of the proximity to the sea. So even though it's classified as the same climate zone, it's clear that there are differences in the climate. If we look into our own data in Qatar, even though it's a rather small country compared to the rest of the land, we can already see some differences between inland and onshore. So what you can see here is histograms of the temperature taken over 3 years, hourly average temperature, ambient temperature, not module, ambient temperature. And you can see that inland, there are some parts in the histogram which is higher temperature, above 40 and all the way up to 50 degrees, which you see less in the coast. And that's only a difference that we see in the country. So the message here is that those kind of differences needs to be taken into account. And I'm thanking the air quality team for preparing the data and providing this information. So what is up to now an homogeneous climate zone as per Köppen-Geiger classification needs to be looked into in more details. And that is what the team in the US, Karin, Jones, and Jane in Sandia has been doing. They've proposed a new photovoltaic degradation climate zone. So I'm mentioning it here, and I will keep the scientific part brief, but I think it's important that all of us have in mind that the stressors, the climate stressors, include not only the temperature, but also the specific humidity and the wind. And I know that Miguel will talk again about the wind afterwards. So taking, for example, the temperature, we know that most degradation mechanisms are activated by temperature. They usually follow an Arrhenius law, and the team in the US have proposed to calculate an equivalent temperature which takes into consideration all module temperature throughout the year. Why is it important? It's important because we cannot assess the degradation parameter and the environmental stress only from the ambient temperature. You have to look at the module temperature, and you have to be able to compare what happens in different places, because even though they are classified as desert, they don't necessarily operate the same. Other combined stressors are very, very important to look at. Humidity, already mentioned, UV, wind load, and the corrosive atmosphere, which is often not sufficiently looked into. Those parameters can vary significantly for the climate zones, even though they are normally considered similar. So if I take these charts, which are available from the internet, you can see the link here from the same team, you see that when you calculate the equivalent temperature, you end up with something which is, again, rather homogeneous throughout the MENA region. However, if you look at our own data, I've shown you before what was you can see from inland and onshore, and this you can see more or less 1 year data plotted at the hour range, temperature and humidity, and it shows that we have temperature which is ambient, which goes above up to 40, 45 degrees, and the humidity which can go up to 60 or even higher, 70%. But what is important is that this is ambient temperature. If you actually look at the 1 minute time step on module in July, this is the histogram that you get. You will go well above 45 degrees. You actually go above 70 degrees, even 75 in some cases. So the message here is that if you want to have a good information about what will happen to your PV systems, you need to look at what is happening on site where you're planning to build the plant, because this high temperature will be the one which will activate the degradation mechanism faster. And I'm talking only about a measurement which is on the backside of the module and without hotspot. So if you have hotspot, it gets even worse. Continuing with the other climate stresses, we briefly touched about humidity. I think it's important to mention that the same chart, again from the same team, when you look at the humidity, it shows that Qatar is a bit more green than the rest of the peninsula, of the Arabian Peninsula. But what we have to keep in mind is that in August and September, even though the relative humidity in average is in the 55% range, the temperature is very high. And that means that the specific humidity, the amount of water you have per kilo or per cubic meter of air, is especially high as well. And that is not dry air, I would say. It's very humid, and it also carries some corrosion from the sea, because there's a lot of evaporation and some chlorine which is brought along. Other stressors which need to be looked into when you want to build PV systems in this environment is the wind speed. I'm just mentioning it here because, again, Miguel will talk about it more afterwards, but you can see that in the peninsula, there are quite significantly high wind speed that needs to be taken care of. We don't have the same hurricanes in the US, but nevertheless, during the storm, it's important. And another factor which I want to stress is the corrosivity, because especially in Qatar, but also in all the coastal region, we have a lot of saline atmosphere on modules. And contrary to other places in India or Singapore, there's no rain to wash it off. So if this part is not washed or cleaned during the operation, it can have some consequences on the systems. Moving on to another issue which we see often in desert environment is the soiling. So you can see on the top part 2 pictures, the same modules before and after cleaning, after a very, very bad soiling event caused by the storm. We have extensive work in QEERI on this kind of problematic and how to mitigate it. We published some of it in the PV Tech Power, and the few things I want to mention to you today is summarized here. If you look at the orange rectangle, which you don't see so well on the screen, but on the left side, I've circled UAE, Egypt, Saudi Arabia, Turkey. You can see that it's the same as we have in Qatar, losses up to 0.4 to 0.5% a day, excluding sandstorms. And when you have large sandstorms, you can lose more than 50% of the power overnight almost. And that's what the panel look like, is on the upper part left. So the message here is that soiling has to be taken into consideration because you will lose a lot of power and therefore a lot of energy. And there's not a lot of rain in the desert, so it's difficult to expect that it will wash off by itself. And also low water availability, which means that the cleaning needs to be tuned for those conditions. Finally, I will now go to the QEERI outdoor test facility. So it's an area which is 35,000 square meters, which has been operated since 2013. We have tested all kinds of PV system technologies: polycrystalline, monocrystalline, heterojunction, thin films, tandem, megacrystalline amorphous, CATL, CIGS, and concentration PV. As you can see, there are quite a few stands. All of them are operated as strings, not as single modules. And we have been comparing fixed tilt and tracker. And the early result we got with the old tracker, which I'm showing now, proved that it was interesting to follow the sun in Qatar to have the extra energy. But what we are looking for now is more to optimize for bifacial modules. And bifacial modules tracker is what Soltec does. And they're proposing this SF7 with both sides to optimize the energy we get from modules, not only from the front side, but also from the back side. Finally, the other thing that QEERI has been doing is we've set up the research consortium, which we call the QEERI Solar Consortium in 2018. It's a research body with international companies and local stakeholders, which include DSM, Anwar QCell, NICE, Total, and local stakeholders like the Ministry of Energy and Industry and Karama. And we also are proud today to announce that, I have a slide which is not moving. Yes, that's it. So Soltec has joined recently the consortium because they are interested to install with us some of their new equipment in our test facility to be able to test the amount of energy that we can get and how well their equipment can work in the desert environment and the solar energy we can obtain. So to conclude, degradation of photovoltaic systems is due to the higher value stresses, not to average conditions, and those higher value stresses needs to be known. The typical Köppen-Geiger climatic zones, they do not provide a full picture of the climate stresses. They need to be considered as per the site specificities. The environmental conditions in the Middle East and in desert location are diverse, and they can stress selectively part or all of the PV components. So they need to be looked into one by one, not only modules, also inverters, also trackers if you've put in or stand. The photovoltaic systems which are planned to be used in those locations need to be designed and tested to be able to guarantee that they will last for the 25 years we expect them to, or longer. And it's obviously preferable to have the track record and to test and demonstrate the technology at small scale before going to larger, and we can support that before the large investment for gigawatt. QEERI is glad to welcome Soltec as the new member of the Solar Consortiums, and I'll finish by taking a quote from Frank Sinatra. He said that if you can make it in New York for people, you can make it anywhere. Well, I think for PV systems, if you can make it in Qatar, you can make it anywhere. And we have space available in our test facility to have future collaboration. With that, I thank you, and I'll take your question at the end of the seminars.
Thank you very much, Cedric. Quoting Frank Sinatra, I think is a first here, so it's good to rock and roll this a little bit. Okay, so let me take your screen off, and indeed we'll take the questions thereafter. And Miguel, you're the next, so why don't you prepare for your presentation? There's a lot of things that Cedric said here, but I think the one takeaway is the last thing that you said, that indeed, once the equipment is ready for desert conditions, they can make it almost anywhere. So just go for those manufacturers that have worked there. So Miguel, you're ready? We can see your screen. Beautiful picture. Can you unmute your microphone?
Yes, sir. Let me know if, can you hear me now correctly? Okay.
We can hear you well, but if I can't, at some point, I'll let you know so you can, because you know.
Okay, put it closer.
Cool.
Perfect. Okay, thank you very much, Cedric. That was a very good presentation to put everyone on the importance of all these factors that are kind of stressed our projects in the desert. And I wanted to start with this picture to say like the main aspects that we face when we started to analyze a project in the desert. First of all, We can see the need of flexibility. We need to adapt to different soil conditions, to different slopes, to the uncertainty of what we are going to find under the soil. Then we can see, as Sally was saying before, like extremely good albedo is a natural source that we have there that we can take advantage of without any need of modifying. We can see lack of civilization, so it's a lack of data, accurate data for everything. Before was mentioning about the wind, about corrosion. There are many things now about the soil definition that we cannot know. So there's a lot of uncertainty. And finally, we can see a lot of sun. So there is where being needs to help us not to clean these models, not to be able to produce as much as we can. So today in my presentation, I will focus on, let me see here. I will focus on 5 keys. First of all, I will introduce very short words about Soltec and the increasing importance of PV trackers, not just in monofacial, but now in bifacial for desert conditions. I will talk about albedo. It's a gold mine in the desert. I will go through atmospheric corrosion. It's the forgotten one. We hear a lot about soil corrosion in every project, but it seems like atmospheric corrosion is not there, and it's a key aspect in the design of a PV plant, especially from the tracker perspective. I will follow up with wind definition and how important it is to be accurate in order to give safety and also cost effectiveness to the plant. And I will finalize with few words on the integration of automated cleaning to link with beam presentation. I will talk from the tracker point of view. So first of all, about Soltec, we have been working in solar trackers since 2004 with dual axis trackers. Then we moved to single axis trackers 10 years ago. We have 1,600 employees, 13 international offices. We are the 3rd global supplier of PV trackers with more than 10 gigawatts already sold. More than 30% of them are bifacial, and we have been ranked #1 in LATAM, in Europe, and we have a strong focus now in Middle East region. Why so? We have seen like single axis tracking has become the standard solution for the structure worldwide, and we are seeing that in these desertic locations, bifacial PV tracking is becoming a must, and we are seeing in all the large-scale tenders, in Oman, in Emirates, in Saudi Arabia, in Qatar, in Kuwait. All of them are using bifacial PV trackers. So we need to see why this is happening, and also we need to improve the efficiency of this plant. So the main role of single-axis tracker is because it acts as the main support of the entire PV plant. It supports the PV modules, which are the main component of the plant. It supports the foundation and corrosion risk. So, and any aspect regarding the use of concrete foundation, soil corrosion, will need to be taken by the tracker itself. And it supports the climate threats in terms of corrosion, in terms of wind, in terms of hailing, in terms of any outer event that can happen. So it needs to be prepared. It's the only device in the plant that is specifically designed for the site, and it can boost the bifacial performance. We are comparing to fixed structure. A tracker can give between 15–25% higher production. When we combine with bifacial, we will show later, it can go up to 35% under good albedo conditions. So what was happening in desert conditions? Why is bifacial becoming the most important or the standard configuration? I call it the gold mine in the desert. It's something that we have there. We are getting for free, and we don't need to do anything on the side to improve this albedo. So our first experience at Soltec with bifacial at desert was in 2015. Was the first project that we were analyzing for bifacial configuration. The client asked us to provide a solution that could be adapted to these conditions, so that could free all the rear part of the modules in the plant to ensure the maximized production. So we create this first 2P tracker, not to portrait, leaving a gap for the torque tube, no cabling, all the cables were going inside torque tube. And after 1 year of performance, our client published an article that was showing this 12.8% bifacial gain. So we realized this was something that was going to happen. So next move was to open a bifacial lab in order to analyze all the parameters that could be relevant in order to both optimize the tracker design, optimize the algorithm of tracking, and also realize how much was the bifacial gain caused by each of these elements. So in July 2018, we opened BITEC, Bifacial Tracking Evaluation Center in California, together with Black & Veatch, RL, RTC, and a few of the most important Tier 1 model manufacturers, Cinco Solar, Canadian Solar, London, Howard Cells, LG, IC. And we were analyzing with two different configurations, two portrait, one portrait, different GCRs, 10 meter speeds, 875 and 12, and different albedos, which is where I want to focus today. We were analyzing 3 different albedos. One of them was seasonal, with variation through the different seasons, gravel, that is kind of similar to what we can find in the desert location, and a white with a geotextile simulating a higher albedo. So we have like these 3 for 16 to 23% albedo in the seasonal, 24 to 36 in the gravel, and over 50% in the white. After running different analyses during the last 2 years, we have seen this kind of linear trend of bifacial gain when compared to different albedos. So as you can see, and Sally was mentioning before, also like for desert albedos, we can see are usually between 25 to 40%. We can see bifacial gains between 9 and 13%, which is quite good, being something natural. It doesn't need any modification of the soil before construction. It doesn't need any OPEX after construction. So it's something that is got that by installing these PV modules on this bifacial tracking. This graph here that will be shared with the presentation is taking into account a 2P bifacial tracker. So it produces 2.1% higher bifacial gain than standard 1P trackers that are positioned at 1.35 meters to the ground, have rear shading. So it's also important to take into account. As you can see in the graph in the right, in the Sankey diagram, you can see that we have 2 components on the albedo. We have a front albedo, like is usually slightly increased by modification on the soil albedo. And the rear albedo, that in bifacial technology is the one that we can maximize. You can see in the very right of the orange part of the Sankey diagram. And this is the part where we want to optimize the gain produced by this rear albedo. The second aspect I was mentioning before was about atmospheric corrosion. When we analyze a project, we see usually that the client is providing a geotechnical report that has a chemical analysis of all the soil, the different parts of the PV plant, and also usually has measurements of resistivity and other aspects. So soil is usually very well defined. However, atmospheric corrosion is not generally detailed. Usually, PV plants rely on very basic information about the location of the PV plant, distance to the sea, distance to maybe power plant or some saline area nearby, and it's not usually measured to provide accurate data so the tracker can be designed. As you can see in the picture in the left, there is only the pile the embedded pile suffering from soil corrosion. However, all other items are suffering atmospheric corrosion. So it's extremely important to define properly this what corrosivity class we are in. So we recommend to conduct the standard test for atmospheric corrosion according to ISO 9223, which they require 12-month exposure of carbon steel coupons. And after this, it's very easy to determine if we are in a C2, C3, C4, and it really adds value to the project because it avoids this corrosion risk in the long term. Regarding the wind in the desert locations, there is one issue that comes from this absence of reliable information. In desertic locations, usually there is no civilization, there is no weather station, so it's complicated to come to an actual value for the maximum wind speed. So generally, what happens is that a value is taken without proved analysis behind. So it's very important to come up with the exact wind speed that we can face in one side, both maximum wind speed and directionality, in order to get a safe design and cost-effective design. It's very common to find extremely high values for wind speed because of this lack of information. So typical sources of wind information are local weather station. Also, in some cases where there is no long-term wind data that can be reached for a site, it can be done an interpolation between several wind stations that are near the project. And in some regions, as in Middle East, we can find that none of these cases are possible. So this it can be conducted a weather research and forecasting model. I would like to show you like a successful case that was conducted in the Middle East by a wind consultancy at WDI. That was during the last 3-4 years. They have been analyzing the different weather information around the Arabic Peninsula to conduct this analysis. They have proved, and they are starting to include this in the local codes. So just to summarize briefly, they were contracted to give contour values for design wind speed for the GSO member, Saudi Arabia, UAE, Kuwait, Bahrain, Oman, Yemen. And what they did is they took all the long-term weather data from the stations that you can see in the top left picture. From this data, they mark contour conditions, and they using this WRF tool, they were able to create, replicate the wind flows for a 50-year return period and higher return periods. They validate with actual stations in the airports in the region to create the map that you can see in the down left, and also to apply these maps to official codes like the Saudi Arabia code as using this wind map. You can see in the down right picture. I put the source of this article. I think it's a very good piece of information, and it's giving light into this wind definition in Middle East that for the last 2-3 years was a little bit blurry. Finally, to link with BIM, I like to mention how automated cleaning integration is coming into this scenario. Like we have been dealing with robot integration for the last 2-3 years, different concepts. Now we are seeing that there is a standardization that is going in line with what Tetra is exposing, like a robot that can cover a high range that requires low-cost bridges to pass for middle parts of the tracker if there is any gap, and that can jump, taking into account the angular tolerances of design from tracker to tracker, and can reach up to 23 string trackers, so 60 strings covered by a single robot. So from a tracker perspective, what we are trying to do here is to help the integration by close communication with the robot suppliers. We are allowing wide tolerances of design, so a robot integration doesn't mean to reduce the tolerance of installation of any tracker, so this can keep high installation rates. Also minimizing the cost of all these elements, reducing the number of dock stations, so we can have the robot passing from tracker to tracker using bridges and reverse stations to come back. And ensuring that the communication between the tracker and the robot is key in order to optimize the operation of the robot, so that the robot can move freely on the top of the tracker, knowing exactly when it can pass from one to another and when it needs to stay in a safe position. And finally, it's very important to analyze this from a layout perspective, going to the real area, plant area, and optimize the north-south, the rows of trackers that can be covered by a single row. This can reduce a lot the capex in a plant. So my colleague Bimin will go through it afterwards. And just to wrap up the 5 items I was mentioning, bifacial PV trackers, they are getting they are the key support PV plant, and they are a bifacial gain booster. We have seen the desert albedo combined with the bifacial tracker can provide between 9 and 13% bifacial gain without any additional maintenance. Atmospheric corrosion requires more attention. It's very important to minimize corrosion risk during the 25-30 years operation of the plant. The wind definition is very important to have accurate information. In Middle East, we have this WRF tool that was published by AWDI that is getting in the official codes in the region. I think it's a very good and accurate tool of information. And finally, automatic cleaning is becoming the standard, and it has a key role to minimize the capex and also the OPEX, and to boost the production by minimizing the LCOE. So thank you very much, and the ball to you, Bim Bim.
Thank you very much, Miguel. I'm going to ask you to stop sharing your screen so that we can ask Bing to share hers and also mute her microphone. And, you know, we have actually had a few questions for you come up. So, and both Bing and Cedric have been answering actually the questions that were there before. So please, Cedric, Miguel, keep answering them. And then at the end, we'll take, you know, whichever are remaining or a few that I've kind of gathered from the questions already asked. Bing, I can see your screen. However, have you unmuted your microphone?
Yes.
It's at the top. Yeah, perfect. We can hear you and we can see your presentation. Go ahead.
Okay. So thank you, Miguel and Cedric, for very helpful sharing, and thanks for introduce Tetra. So here today, I'm going to talk from the automatic cleaning perspective. We are Tetra Electronics, and we're based in China, Nanjing. And thanks for the invitation from Miguel and as well as ATA to really let me introduce this technology specifically towards the desert environment. So, okay. So here's the content of today. For those of you who are not familiar with our technology, I will have a very brief introduction about our product, and then I will go into detail from both technical and commercial perspectives. Okay, so as you can see from the picture on the left-hand side, this is the robot that we are producing, and it is a water-free, fully automatic cleaning robot. It's self-powered, as Miguel already mentioned in his presentation. We offer really reliable bridging, which helps the robot to run smoothly across modules and from tracker to tracker. Also, the robot will be securely locked at the docking station, and the overall communication system is based on cloud. You can control the robot remotely, and is connected to the local weather station, which can help you set up the cleaning task based on the local weather station. Okay, so here is a list of projects that we've done in China. We've already installed about 1 gigawatts within China. Due to most of the projects are government owned, I'm not able to share the power increase data right here, but I can tell you it's roughly from 5% to 40%. On the right-hand side, here are some highlights of the projects. With this project, there are some severe weather conditions involved. For example, minus 30-degree temperature, and anti-corrosion is applied in certain projects. Some of the projects are located at places with wind speed up to 70 kilometers per hour, and so on and so forth. So in the next slide, I want to showcase a project which is similar to the desert condition which we're talking about today. So this project is located in Ningxia, Inchuan, in the northwest of China. It's a relatively small project. We installed 14 robots at the rooftop of a factory, and gladly the power generation has increased by 30%. And as you can see, a very basic, environment data right here. Up to 37 degrees. I'm sure, in Middle East area or desert locations must be higher, but we are conducting some tests later on in the MENA area, but due to the COVID-19, it has been postponed. So a couple of tasks that you need to run before we have the robot installed. on the PV plants. First one is the one that a lot of our clients care the most, is about the cleaning efficiency test. This one I'm showing right here is a test that we've done in-house in our robot test center. As you can see right here is the layout and the measure points, the setup of the test. Right here is the automatic dust control. We use two different types of dust. One is imported from the States and one is local talc powder. And here is the control system of the dust spray. So we did 4 groups of tests to really see how the dust will affect the light transmission of the glass and with and without the cleaning. So to give you an example of one of the test number 2 that we've done with applying talc powder 2 times, as you can see here is the data of transmission before the dust, and then here's data of transmission after the dust. Right here is for one-way cleaning. As you can see right here, the blue column, and the last one is the with the backway cleaning, which is the orange column right here. So here is the cleaning rate, as you can see, with the round trip, like one way plus the backway cleaning. As for this test results, all 4 groups of tests, the fourth way cleaning definitely cleans most of the test. It reaches up to 98.9%, and for if you do a round trip cleaning, some of them can even reach 100% of cleaning, depending on the density of the dust and also the other environment factors. So here is the second important task that we do, which will, as Miguel already mentioned earlier. So as for the structure compatibility test, we do fixed structure, as you can see right here, is the docking station, the bridges, and the reversing frame, which helps the robot to travel back. Here is the flat single axis structure, pretty much the similar design. However, for different trackers, we do involve different structure design. As you can see here are a couple of examples. As Miguel already mentioned earlier, here is the compatibility test that we've done with Soltec SF7. The first one is the module adaptation test, which helps us to really define if the robot can run smoothly across modules with different heights, and also the tracker crossing test. As you can see, the setup in our testing center, you really need to overcome the differences of horizontal, slope, and angular in different dimensions. Okay, the third important test is the module performance test. So this one we did with one of the well-known module suppliers. In their testing center, we simulate 25 years of lifetime of the PV module, and in their laboratory, we simulate the overall test before and after wiping the module. There are 5 tests we've done. I'm not going to go into detail, but what I really want to point out here is that there's definitely influence on the module itself. As you can see, I highlighted the numbers here, minus to 1% for the maximum power differences over the time period of 25 years, and also here. But the thing is that the number comparing to the overall lifetime span of the cleaning cycle, is relatively small. Okay, so going into the commercial part, I want to take you through the overall project pathway. There are 4 major stages once we work with our clients: planning, commissioning, operation, and maintenance. One thing I really want to point out here is the planning stage, because this is the most important stage. So at this stage, we work very collaboratively with developers, EPCs, module providers, and structure providers. The goal here is really to optimize the design, because as Miguel already mentioned, the most optimized design will really help us to save the initial CAPEX, and also to really have the local weather condition, as Cedric already mentioned, with all this severe weather condition you really need to take into consideration involve, like say the wind speed, the corrosion, and the humidity, all of that. Because at this stage, if we evaluate the project is able to go with the robot, our technical team will have full support. And then, at the commissioning, operation, and maintenance, it should not be a problem because our professional technical team will be on the side and support the project all the way through. Okay, a couple of the needs that we've collected from our clients who have projects in the desert environment. So first, fully autonomous. As you may know, in the market, there are a couple of other options: semi-automatic or manual cleaning, or like with water cleaning and all that sorts. But nowadays, what we've known from our clients are that they're really looking for safe cleaning without any human intervention, which really exclude the semi-automatic cleaning and water cleaning in many ways. Also, frequency. With our clients from Australia and South America, they might require cleaning every 2 times a week, 3 times a week. But with MENA area, mostly they require daily cleaning, which actually helps to optimize the cost because you clean more frequent and you have like a better LCOE. Okay, and reliable. To make sure the robot runs smoothly across modules between trackers and able to withstand wind speed and all the severe weather condition. Effective, again, we need to conduct more tasks in terms of the cleaning frequency, cleaning efficiency, soling rate, so on and so forth. A little bit in detail about the cost. So when you think about using robot for your project, for the CAPEX park, there are 3 major elements: the robot itself, the supporting structure, and the manpower for installation. As for the OPEX, there are the spare parts for the robots over the lifetime of the project, and again, the manpower. So what I'm trying to say here is that the robot cleaning is not for every single PV plant, but for the desert area is definitely the market that our company is trying to focus on, and also the area which really needs the robotic cleaning due to the severe weather condition and definitely the desert area. So what we do is that we definitely evaluate the project really ahead of time, really understand the environment, understand the overall project, and to let our clients know if robot cleaning is the most optimal solution for you. So to wrap up the presentation, I think it's actually reflecting what Miguel was saying earlier. So what we try to do is, like with PV module, we go from monofacial to bifacial. From about structure, we go from fixed to trackers. And then what we trying to do, Tetra Electronics, we really want to, at the OM stage, to replace manual cleaning with our autonomous and intelligent cleaning. Thank you very much. I have my email address right here if you have any questions.
Thank you very much, Bing. Thank you very much for this interesting presentation. I'm going to ask you to take it off the screen now so we can see you better. Let me see, I can do that for you actually. And we have a lot of questions open, 20 as of now. So we're gonna go through some of those, but like there seems to be some running topics. So I wanted to start with those and then, see where we get at because we have about 10 minutes. So the first one that came up a few times was, what does it mean, cleaning efficiency? People seem to have, how do you measure it? What does it mean? There are several along those lines. How do you test it? What tests are cleaning efficiency tests? So do you wanna talk a little bit more about that? I don't know, Bing, probably you're the best person for this, but then we can see from there.
Okay. As for the cleaning efficiency, the task that I've shown here is the in-house task that we've done. We have 2 upcoming tasks in Middle East area, which will have give us a better understanding of the desert locations, and the data should be more accurate. But as for cleaning efficiency, it's definitely related to the soling rate, soling loss that caused, by the weather condition there. Cleaning efficiency you could define as, with cleaning by robot, what kind of cleaning efficiency that it can bring up to. So say 99%. That you can also understand it as an availability. Does that help you answering the question?
I think so. I mean, do you guys want to add anything, Cedric, Miguel? But there seems to be a lot of questions about that. So clearly, maybe people don't really quite understand what is like, how you test it, I suppose. But it's a cost opportunity, essentially. This is where I understand between actually what it costs to clean and what you lose out in terms of the losses themselves. Another question that ran quite a bit, and some of them we've already asked, is how do you clean the back of the panels? Can you do this with a robot? Is it an easy way to do it? Should you clean it? How often should you clean it? There was a bunch of questions about that. So I don't know, Bing, if you want to also approach that specific question.
Okay, so as of now, we don't have a solution for cleaning the back of the panels. Due to the cost factor, I mean, there's definitely some other solutions for the back, but it's very expensive at this stage. So nobody's actually doing it. But, you know, as for now, we're only cleaning the top of the panels.
Yeah, based on our experience at Soltec, we haven't seen much interest on cleaning the rear side because of you have the gravitational impact. Also the air when it's reaching if the tracker is facing west, when the air comes from the east, it does kind of some self-cleaning. And as we were seeing, the bifacial gain is usually about 10-15%. So it's 10 times higher, the impact of dust on the front side compared to the rear side. Maybe Cedric has been analyzed this, can add something.
Yeah, I can comment. I've had some comment on that. It's indeed the soiling mechanism on the back side and the front side are completely different. And what you can gain from removing the dust is definitely not the same. So I think this is I've seen it a running question, but I think the cleaning of the front side is much more important regarding cost and also much more practical to do with the robots. So.
There's actually a follow-up question here. It says for Soltec, but I'll open up to any of you. Any data on soiling reduction when using trackers? Or the measurement of soiling accumulated on the front and the rear side? Maybe it kind of like fits in with the past question.
This is something that we're starting to analyze. We haven't yet got detailed numbers, but it's something that we are proposing in our research in the Middle East. So hope to have something soon, but not right now. We don't have available data.
Okay, guys, can I ask you a question that is a little bit more generic? It's not there, but I think it's important. We have people from Chile. You've mentioned the desert in China. We've talked extensively about the Arabian Peninsula, but there is also, I think we touched upon, Chile a little bit, or there are people from Chile anyway in here. There are certainly a lot of deserts and they're different. How much can it be learned from one another, and how does it differ in terms of when I'm preparing a project? What should I account for, I suppose, differently when learning from different regions? Cedric, I think this is more for you, but then maybe Miguel and Vin, you can add.
Yeah, I'll start. I think what I wanted to show during the presentation is that even though the deserts all together have similarities, there are definitely some changes regarding the dust which will fall on the modules. And in QEERI, for instance, we have studied a lot the paleogardsite needle, which we can find in the Arabian Peninsula, which tend to catch dust particles and keep them here, which we call cementation or caking, depending on how you want to call it. That makes it very difficult. So I think what you need to look at is the kind of material that will fall on your panel, whether it's only mineral, whether there's some organics, whether there's some soot if you're close to an a plant which can produce some fumes. And that's what you need to look at. And definitely all sites are not going to be the same. So we'll have general patterns, but I think you need to have a good planning from the start, as Ben was saying at the beginning.
So you actually said you have to run tests on that site in advance, or?
I say you have to know what are the climatic conditions and the soil that you will be looking at when you are doing your plant, if you want to do the optimum.
Okay, Miguel, you guys have run tests also in the Mojave, right? Or in the US?
Yes, our tests were conducted in California, in Livermore, California. Linking to the question you were mentioning, like we have taken a lot of experience from our first plants in Chile. No, we conducted a few hundred megawatts in those DSS, and there is a lot of learning we have taken from that, especially for the common aspects that happen in all the DSS. So like especially for extreme temperature, we have been able to design the tracker for extreme conditions in other locations, but there are like regarding atmospheric corrosion or regarding soil conditions, this can vary a lot from one side to another. So extreme temperature, abrasion can also be one of the important ones, and bifacial behavior, we can extrapolate. Other ones we need to understand the specific area.
Okay, so I have one more question for you, Miguel, and Bean and Cedric, take a look, and if there is any that you'd like to resolve, then you can do it after, because we're a bit short on time. Here, GD Lido asks, do you have a specific product line for trackers for desertic conditions in consideration of the highly dusty environment? For you, Miguel?
Oh, okay. The main impact that the dust environment creates on the tracker is regarding erosion, abrasion, and corrosion. Like, so the main risk that we can have in this environment related to dust is that the pre-galvanization can be removed because of the impact of this soil. We are conducting tests, and generally in sites that have high wind speed and sandstorms, we recommend to go for higher protection. So it's not a change of design; it's more a change on the protection. No? So we will go to higher, like hot degalvanization or CM solution.
Right, Cedric Bing, have you taken a look at the questions? Is there any that you'd like to answer live? Why don't you start, Cedric? If you have one, we can't hear you at the moment. Just unmute yourself.
Yeah, I was actually typing
an answer. Yeah, maybe you can do it live then.
Yeah, the numbers of cleanings, or whether it impacts the anti-reflective coating. So I think it can. It's a domain of research in which we are strongly involved. And I think it will depend also on the anti-reflective coating we're talking about, because there are several different solutions, and also the cleaning solution. So all of that is are definitely questions which are being researched right now, but we don't have all the answers yet. But yes, the answer to the specific question is yes, it can have some impact on the anti-reflective coating.
Bing, how about you? Is there any question specific that you think would be interesting to answer live?
Yes, I do have one question from Pajol, and he said, how did the water-free deal with the panel guarantee? So again, two parts. First, as for the panel guarantee, is really different from module suppliers. From say one specific module suppliers definitely has their own measurements and own methods to measure the impact on the robot. So that's why we are approaching different module suppliers to really have the certification from their sides. And the second, in terms of water-free, there are actually white papers out there talking about how water cleaning versus water-free cleaning are different, and how water is actually might causing certain damage to the panels. But for us, water cleaning is not an option. We do all water-free cleaning. So again, for this question, might just in terms of getting certification from the panel specific module suppliers.
Okay, since we ran out of time and we have 25 questions open, and there is absolutely no way we're going to sadly get through all of those, because many of them are very, very interesting as well. Some of them, they tend to ask similar things. So I think we're in the ballpark, but I think if we started going into detail, we'll take another hour. So I'm going to pass on the questions to the speakers, but also you have their details. So by all means, get in touch with your specific questions. In any case, most of the questions that you ask probably need some extra detail to be able to help you. I'd like to thank Cedric, Miguel, and Bing for being here with us today and for sharing your know-how with us. And we're going to see more and more desert PV projects. You just have to look at how much the Middle East is growing, and it just seems like good business, good economics. And there is the fact that the albedo is extremely high in deserts. So I'd like to also thank our audience, and I actually would like to encourage you to get in touch with our speakers today, if you have any further inquiries, or if perhaps you need their help with something. And other than that, thank you again, and see you next time.